Today, we're going to learn some of the strategies that experienced teachers use to make up problems. You will be doing this in class shortly, and I hope that these tips will help you when you have to make up your own problems. So suppose I'm going to be making up an exam for this class, and I decided I wanted to do a problem on an inclined plane. So the first thing absolutely I would do is draw a picture of the inclined plane and put some things on it. So I might want to put a box on here. I have to decide whether or not I want friction, and I probably am going to not have any friction in this problem. It's best to often make up a simpler problem, and then you can add the complication like friction in afterwards. So what might be something you'd want to determine about this object? Perhaps one of the most obvious things is to determine the speed of the block at the bottom of the hill. And now, this is the tough part. We need to give just enough information so that the problem can be solved, and if we leave out any information, we'll find that we have no solution. So let's give the object a mass of nice easy number like 2 kilograms. Okay. And let's give the height of the hill to be 8 meters. Okay. Note also these are reasonable numbers. I guess 8 meters is a pretty high hill, but maybe this could be like a skier or something like that with no friction. Okay, although the weight's a little bit low of 2 kilograms, but okay, we'll go with these numbers for now. But it's always good to make sense of your numbers and make sure they're not completely off. Like I wouldn't want to do a height of, say, for a skier, we would never do a height of 800 meters. That's probably way off. Okay, so given that information, we want to find and we need to identify the speed at the bottom. So this to me looks like a conservation of energy problem. So first I identify the physics principle that I'm going to be using. So there's potential energy in here. So I recall the formula for that. And there's also kinetic energy involved, and I recall the formula for that. Okay, so since I've already given the value of the mass, we can kind of put a little check on top of that. And we've given the value of the height, and we know g, so it looks like we might have enough information to actually solve this problem. So using conservation of energy, we set the potential energy at the top equal to the kinetic energy at the bottom. So we get mgh equals 1/2 mv squared. Notice I really didn't need to tell you what the mass was. And let's put in some numbers. G is about 10. H we were given as 8 equals 1/2 v squared. And if we pop those numbers into our calculator, we get a velocity of approximately 12.6 meters per second. Now, note if I was going to be putting this on an exam, I would want to recheck my work actually several times. And one way to recheck your work is to work the problem backwards. So let's go ahead and work this problem backwards in green. Okay, so working it backwards, we might say, given the velocity at the bottom is equal to 12.6 meters per second, find the height, h. Okay, so once again, we know that 1/2 mv squared is equal to mgh. The m's go away. Oops, the 1/2 did not go away. And we have 1/2 times 12.6 squared equals 10h. And putting that in our calculator, and we get h equals 7.94, which does agree within rounding errors.